Good morning, sir. My name is Timothy Thomas George, registration number 20BC 1278. My J component project is a review paper and it is titled Fault Tolerance Priorities in Software Design. I have done this project individually, and the entire review, analysis, and report was done by me. Introduction to this topic. We know that software has now gained a lot of applications in today's world, and these applications are sometimes mission critical applications. For example, space exploration, hospital surgeries, and these are applications where if something goes wrong, the result could be fatal. It could be very bad. These are mission critical software, and in these cases, it is important that we maintain software reliability and that any faults that happen in the software are taken care of and do not cause major errors. The problem for that we software developers need to tackle is where to put this software reliable, where to induce the software fault tolerance. One way is to do it in the software testing. That when you're testing the software, you can test whether exceptions are being raised, how the errors are being handled. And the second option is to do it in software design. In software design, we can design the software so that it is fault tolerant. That if there are any exceptions that are raised, they are handled properly. That the software is designed only that way. So of these two options, software design and software testing, software design has been seen as more effective, as we will see in the next slide. So related work with this topic. A lot of researchers have talked about how software needs to be reliant and fault tolerant, and about software stability. Different researchers have different ideas about software stability. Some say how it survives in the environment, and some talk about how it evolves during the development cycle, and also about software assembly. Software assembling, researchers talk about is that nowadays we may not need to write a lot of software. We may have predefined sets of code, and we assemble these together to make a program. Another thing literature talks about is the importance of software design, because if you design something properly, then you lot of problems that you will face in the other phases like maintenance phase and testing phase, they can be avoided because you take care of these things in the design phase. And literature has got to so much that they have even defined certain practices, such as recovery blocks. And these practices they ensure that the software is fault tolerant. For example, recovery blocks. They say that when a fault has happened and the software needs to recover, execute this new set of code, this code, so that the software can maybe do something else or revert to its original. So this comes to my the research questions for my project. Research question number 1. What is the current state of fault tolerance in software design? Or in other words, in today's software designs, how is fault tolerance induced? Is it induced? Do they include reliability in software design? Is it a priority? That is my research question 1. My research question 2 is, what are the practices used by researchers to incorporate fault tolerance in their software design? Or in other words, this is assuming that we find that reliability is prioritized in software design. If so, what are the practices that the researchers are using? What are the specific methods like recovery blocks? Today, what are the researchers using? What are they putting into their software design so that they can make it fault tolerant? So how I have conducted this review. I have taken 80 research papers in total, and this has been from the past decade for 10 years, from 2012 to 2021. That means per year I have taken 8 papers, and total 8 into 10, I have got 80. And the type of papers that I have selected are related to researchers. They are reporting their newly designed software, or they have made near novel architecture. Anywhere where they're talking about software design, I have selected those papers. And the exact search key that I have used to collect the papers, I have included in my report. And then I have finally analyzed these papers with respect to research question 1 and 2. Okay, data collection. These are the table on the left shows my sources for the different papers. Out of the 80, they included sources like Google Scholar, IEEE Explorer, Springer Link, ACM Digital Library, university database, because some of these were dissertations and some were theses, and they were only available on the particular university's research database, and then Science Direct. And the type of papers that are surveyed, they include mostly of journal articles and conference papers, and fewer others. Others included dissertations, like I said before, and technical reports, book chapters, and magazine articles. Magazine articles, some professors have written about the importance of software design, and they've given it in their university magazines or in some other technical magazine. And now the result. Out of 80 papers, I found that 1/3, that is 33.75% exactly, 27 papers were discussed reliability. That means 1/3 of the papers about software design had reliability included in them. And the papers that did include reliability did include fault tolerance. These were more of theoretical papers that were talking about theoretical designs, and in contrast to researchers reporting practical design that they implemented somewhere and they're talking about. And studies that discuss reliability, we can see that most of the studies were journal articles and less were conference papers, and the lesser were the remaining. Reliability papers by topic. As I had said before, most of the papers were of theoretical model, those who discussed reliability. Most of them were theoretical model. There were a few survey papers, analysis papers, and they were a little more novel designs. And as we can see on the chart on the right, as the years go by, there's almost a stable trend from 2015 onwards, 2014, 15, and this has been going almost stable after that. But before that, there was more research papers on this. Okay, my observations. There were many more design practices that were found, more than how much I had done in my initial study. And I have analyzed all these design practices and reliability as a reason. One thing I found in many of those papers was that researchers would write about one particular method that they were using, and reliability would be a side reason. For example, they would say that we are designing this energy producing, the software for this energy producing component, and we are going to use many components instead of a single one. And the main reason they are doing that is so that we can save costs. But as a side reason, as an added benefit, they are also talking about reliability. And with all my analysis, I have defined 3 methods to design a reliable software. That is the major contribution of this paper. So this is what I found. Out of all the papers that talked about designing reliable software, half, or 55%, were talked about direct design practices. 30% talked about algorithms, and 15% about data manipulation. If the data practices, these were specific architectures, specific methods, specific things that they did, that they included in their design, that were used, that brought fault tolerance, such as architectures and redundancy. redundancy in the sense that many components doing the same thing. In case one fails, and the other can be taken. And also things like self-healing software and self-checking and components that will check other components. These all come under design practices. Then 30% of the paper talked about algorithms. Algorithms means they design the software, then they use one particular algorithm to make sure that the design is fault tolerant. For example, optimization algorithms. After designing the software, they'll run an optimization algorithm to remove any of those vulnerable uh, areas where fault could occur, and even design synthesis. Many research papers have talked about particular processes, particular algorithms that can synthesize many software designs. And when you design many software, you get synthesize many software designs, then you can make a correct choice based on their fault tolerance. And lastly, 15% talk about data manipulation. Here they were talking about the code that they were doing. They were using particular data formats, particular data structures. These structures, they were purposely using in their programming so that the software could be designed to be reliable. And finally, the conclusions of my paper. Yes, out of 80 papers, only 1/3 had talked about reliability, even though it is very important that they should have included it in the software design. And so more work needs to be done to bring this to the attention of all the software designers. And 3 methods is maybe sufficient, but we must encourage more practices in use. And then about the added benefits and long-term cost saving. When if we design something properly, we make cost savings later on. For example, in the maintenance phase, a lot of costs can be saved if the software was designed properly. If the software is not designed properly, then later when you go for the coding and for the testing and then for the delivering the product, a lot of problems come up. And so we can avoid by taking, yes, making the software design reliable also has an induced cost, but those are made up later on when we don't have to pay for increased maintenance. These are my conclusions. And finally, there's about how we need further research and industry academic disparity. There is, since most of the papers were theoretical, this is one limitation of the paper. Since most were theoretical, papers were theoretical, there may be a difference between what academia is suggesting and what is actually being done in industry. Thank you. And now I will show my project report. This is the paper that I have tried to write on my review, fault tolerance priorities in software design. I have started the abstract. Then I have given an introduction, and I've given one example where it is crucial that fault tolerance of the software was there. And I include here my initial research. I included in my background the initial study that I had done over a few papers, and to understand that people had recognized that software design is important and software architectures. Then is my methodology, the 2 research questions that I used for my review, and how I selected the papers. This is the search term that I used for my to select the papers, and these were the criteria. They had to be either proposing a novel software, reporting a design software, or they were maybe serving particular articles or analyzing particular application software. And 10 years of papers, and how the papers were, the type of papers, which I have shown before, and the sources. The results, the papers that had discussed reliability, and the papers that had answered research question number 1, and also by year. Then finally is my discussion. The papers that answered research question number 1, that is whether fault tolerance is being included in software design, and also talked about reliability as a reason. And then we talk about the 3 methods, 1, 2, and 3, that were about research question number 2, that were what are the particular practices that were being used. And then finally, the 3 methods of reliable software design that I got from my paper. And finally, the applications of my paper are where how this research is beneficial, because that as I said before, in lesser cost during maintenance, and also because of mission critical scenarios. And then finally, the limitations and the future scope of the paper, and then my references. So yes, that is all. Thank you, sir.